So I think we can start right now. Welcome everyone. So in this, my name is Hüseyin Babal, and in this session, I am gonna provide you some information about how we can install Kubernetes from scratch. I know there are lots of managed service in order to use Kubernetes in lots of cloud providers, but here the main idea is install the Kubernetes, and during this installation, let's learn something that relates to Kubernetes core components. Okay, so within this session, we will mostly handle this kind of technologies, Docker machine. So Docker machine will help us to orchestrate some machines. So we will use DigitalOcean in order to install our Kubernetes environment. So Docker machine will be orchestrating the DigitalOcean droplets. Kubernetes is a primary node agent on Kubernetes nodes, and then its main responsibility is to manage the pods lifecycle. So if you create a pod on the Kubernetes environment, this kubelet will be ensured that, okay, this pod works as expected. Mainly will handle the containers. So kubeadmin is the most nature tool in order to install Kubernetes. So basically, we will install the master, and then we will add the node agents to the master node. kubectl, most probably you already know that kubectl is a command line tool in order to do some operations by using Kubernetes server. In order to create missions in DigitalOcean, first you need to create an account on DigitalOcean, and then you need to export two environment variables in order to use Docker machine, because Docker machine can work in two modes. You can provide parameter during the command line execution, or you can define your DigitalOcean environment variables, and then you can execute any kind of Docker machine command. Here, you can grab those informations from the DigitalOcean account and the security page. So the first step is to create those three machines, okay? So we will have only one master and two nodes in the Kubernetes environment. So let's create those three machines first in order to install Kubernetes at top of those machines. Okay, so here, so this Docker machine create command, I am saying that let's use the DigitalOcean driver here. And I selected this DigitalOcean size as 2 vCPU, 8 GB of memory, and the name of the machine will be K8s master. Here I selected 2 vCPU because when you have a look at the minimum requirements of the Kubernetes installation, it will be better to use at least 2 vCPU in the cloud environments. So let me create nodes, because we will then join those nodes into the Kubernetes master. So here I need to set my environment variables. Okay, during the installation, I will add variables in my source profile. Okay, I am about to add my DigitalOcean credentials here. Okay, I will only do source, cool, another source here, cool, and then just create the first node, okay? And on the other section, I will create the second node here. So the first one is okay, right? We have the master node here. When you say Docker machine ls, okay, as you can see here, the first master one is installed, and you can see the Docker version here. I just wanted to use advantage of Docker machine, because when you create machines by using a Docker machine, the Docker engine will also install within the machine, so it will be a plus for us. So we need to wait for the other nodes to be created, and then we will check some installation inside the machines. Right after machine creation, you need to install kubelet inside the agents, okay? So on every node, we need to have kubelet. So this kubelet will be responsible for managing your pods. So here, as you can see, I am trying to install some packages. So the main idea of adding this source is to install kubelet, kubeadmin, and kubectl. Let me try to execute one by, okay. So I just run this command in the wrong place. I need to SSH into the machine first. So this is the master. So another advantage of using Docker machine. Okay, here, let me paste the same command again here. So I simply add some package right after adding this source. The packages are kubelet, kubeadmin, and the kubectl. Kubelet will, as I said, is for the primary node agent. Kubeadmin for installing the Kubernetes, and kubectl is for connecting to the Kubernetes environment. So I will SSH to the SSH. So now it is time for slave one. Okay, it is also installing. Now for slave two. Okay. So right after you installed those tools, in order to continue our session, you need to check that if the C group is supported or not. So when you perform this command, docker info grep C group, okay, I see there is C group driver, C group FS. So this is another requirement of the installation. So you need to be sure that this C group FS is supported in the machines. Okay, same and same. So we can continue with the next step. This installation will be very same with Docker Swarm installation. As you remember, so we need to initialize the master one first. So as I said, our installation tool will be kubeadmin. I am saying that just initialize an installation, and the pod network will be, the network seeder will be this one. So this is very specific to CNI plugins here. So in order to install Kubernetes and use them in a very efficient way, you need to use a container network interface. So we will use Calico in order to do that. So when you check the network interface plugin page, you will see this kind of definitions. So I'm providing this one as my network seeder, saying that, okay, there will be lots of IP address will be created inside the Kubernetes, and this will be the mask of seeder notation of the networking. So let me initialize this one. This will install, as you can see here, detect the C group FS. And as you can see here, this will initialize master node and then provide some kind of command in order to let me run on the node agents. In order to connect the Kubernetes cluster, most probably, if you are using some kind of managed service, they will provide you a configuration for your kubectl. So right after you install this one, the installation configuration, okay, as you can see, the command is here. Let me show you this one, kubeadmin join, etc., etc. And before continue this one, let me export a configuration file within my environment. So here I export this kubeconfig as an environment variable and say kubectl get node. As you can see, there is only one node, which is master. And if you define this environment variable, kubectl will use this name by default. Okay, so this is master, but the status is not ready. When you do a docker ps command here, you will see lots of pods is running. For example, you can see the etcd here. So etcd is the place that Kubernetes store its state. So this is very important component of Kubernetes. And again, you see this API server. So actually, when you perform kubectl commands, it is some kind of command line tool that sends a request to the Kubernetes API server. It just creates a resource, and then your kubelet feed it by these resources in order to create or manage some kind of pods. And this controller manager is for managing the other controllers. We have replication controllers, etc. And scheduler is for scheduling objects to the desired place. Okay, the master is initiated. And then let me join all the other nodes to this master node. I will grab this one. Okay, enter here and wait for it to join, and another join is here. Right after this join operation, we will check the node status. There is only one step left here. Okay, finished. Okay, the nodes are ready right now. Master, okay, the version is this one, cool. So the next step is we will install the Calico plugin. As I said, there should be a container network interface. So you can check Calico here, okay, project Calico, and I will use this version. And there is a definition in this YAML file. So in the next upcoming webinars, I will show you how the Kubernetes deployment services, etc. works. And in order to create that kind of resources, we simply create a YAML file and then put the definition inside it. So this is another definition, and I will try to create this resource in order to apply this network plugin. Okay. So we need to check if this network plugin is working. Okay, as you can see here, the Calico kube controller is here, the container creating, and Calico node. So there are 3 nodes because we have 1 master and 2 nodes. In total, it is 3. Okay, we are sure now that the Calico plugin is correctly installed. And here, as you can see, the status switched to the ready from the not ready state. So we are cool right now. I will mention another topic which may be important to you. Normally, the best practice is to not deploying any kind of worker task inside the master node. So master node is the brain, okay? It only controls the entire cluster. And if you want to deploy something to, for example, microservice, you need to deploy that one into the node agents, okay? So if you want to deploy your object into the master node also, you can use this command. So this taint is another big topic for the Kubernetes installation node properties. So when you say that, and when you try to create a deployment, you will see that this deployment will also capable to deployable into the master node. So I will not do this for this time because I don't wanna make my master node as a worker node. So until this point, we always connect to this cluster by using from the node machine, right? So now, when you have a look at the real life, you need to connect your Kubernetes cluster by using some other management machine, or this time, let it be some kind of my local laptop, okay? So I need to copy the configuration to my local computer, right? So I will do this. Docker machine SCP. So from this machine and inside this machine, by using this path, I will copy this file content to the webinar conf. Okay. And export. So right now I will do this one, and then let's see if it works or not. Okay, since I am connecting from my local computer, it will be a bit slow than expected. Or let me provide the full path of the Kubernetes webinar file. So this is webinar file, and let me pd. Okay, as you can see now I am able to connect my Kubernetes cluster. That means I will close this part. Okay, so we have Kubernetes cluster ready right now. And then, for example, we can deploy the Kubernetes dashboard UI here. So by using that dashboard, you can see your Kubernetes cluster status, and then you can create deployments, you can have a look at the logs, etc. So let's start creating our Kubernetes dashboard component first. As you can see here, again, I am trying to apply some YAML definition file. You can check this content. Let me show you. I'm trying to do a cat, but let me. Okay, this is an HTTP. Let me show you the content here. As you can see, for example, here there is some kind of resources deployments. there is services, etc. So basically, we will apply this YAML definition file. Okay, let me apply this and then see what happens on the background. So the certificates created under the secret, there is service account, there is some kind of roles, role bindings, deployments. So in the upcoming webinars, I will explain you in detail what are those objects. So right now you can think about that. Okay, the necessary objects are created. So this object is created. So we have service, but in order to access this one, I will do a proxy here. Okay. So when you say kubectl proxy, actually you can access your Kubernetes cluster service by using this URL right now. And let me open this admin UI. As you can see, it requires some kind of token or kubeconfig file from you. Okay, there are two kind of access methodology here. So my next step will be to create a service account which is dedicated to this admin UI. And the first step will be creating, here I am simply create a dashboard service account YAML. And then within that YAML file, I have a service account object. And inside the metadata, I provide a name, which is admin user. And right after this file creation, I simply apply this newly created dashboard file. Now the service account is created. When you say kubectl get SA, you will see, but in the kubesystem namespace, when you do this, you will see that there is an admin user here. And right after that, I will create a role binding. So here, this part is important. As you can see, cluster role binding. Here, I am simply saying that, okay, create an admin user role bind, cluster role binding here, and then the role ref is this one. In order to, this is not complete. Let me rephrase this one. So I simply create a dashboard YAML file. Within this YAML, this time it is a cluster role binding object. The name is admin user. As you can see here, I am trying to bind this role. As you can see, this is a role reference. This is a cluster role. Name is cluster admin. And then I am trying to bind this role to this service account, which I just created, okay, within the kubesystem namespace. And of course, apply the file. Okay, the role binding is also okay. And the final step, as you remember, within this UI, you need to provide kubeconfig or a token. So this token is a simple JWT token which created within the service account. In order to grab that service account, you can use this notation. So here, I simply saying that in kubesystem namespace, just describe the secret here, and the secret will be newly created during the last two object creation. So when you do that, you will see there is a JWT token here. I copy this one. I need to proxy again. Let me refresh this page. And in token part, I provide my token and just sign into the system. That's all. So as you can see, I am capable of seeing the nodes, master, slave, slave 2. You can see the roles. And whatever you do in this part, There can be some kind of namespace parameter. For example, here default. Those are the default namespaces. And you can, when you switch the namespace, for example, kube system, and when you go to the role part, you will see the necessary roles also here. You can also paginate here, here. Okay. So inside the Kubernetes, there are lots of workloads, as you can see here: cron jobs, daemon set job, pods. Also, I will mention this part in the upcoming webinars also. When we go back to the slide, we created our machines, we installed the Kubernetes cluster. Now the connection is okay because we installed the Calico plugin, and finally we have our admin dashboard. Okay. What is this? This is Spring Boot application. So let's install this Spring Boot, sample Spring Boot application within this cluster. In order to create a simple Spring Boot application, you can use Spring command line tool. You can easily install this one by using Brew package manager. I am saying that, okay, within this project, there will be a web and actuator dependency. And this time, this name will be something like Hello World. Not Hello World. Kubernetes webinar. Okay, it will simply create the folder, Kubernetes webinar here. And I will just go to the folder and then do a Maven wrapper clean and build. Sorry for that, not build, not a Gradle. Install. So this will create a jar for me. And then I am trying to create this jar because I will use this one within the Docker file. I will simply create a Docker file. Okay. And within this Docker file, the content will be this one, which is very easy. I am saying that just use this as a base image. Copy the jar file under target folder within the current project and to the destination as app jar. And the enter point will be java-jar app.jar. Okay, I created Docker file, and now I will say Docker build -t and Kubernetes webinar. Missing that at the end. So just finished. And then you need to, in order to push this image, I will push, by the way, this image to the Docker Hub, and it will be public. Docker tag Kubernetes webinar. I just tagged it, and now I am ready to push this one to the Docker Hub. Cool. Now it is preparing to send all the image. I am sending this one to Docker Hub because I will create a payload right now, and I just wanted to make this one public. Okay, it may take a bit longer. Okay, most probably it will take a bit longer, but let me abort this one and try to create my next step, which is the Kubernetes workload, in order to show you how we can deploy. By the way, I will use the interactive command instead of YAML definition because there will be lots of information in the upcoming webinars. So I will use the short notation here. So when you say kubectl run, this command is deprecated, but no problem. At the end, it will create a deployment, as you can see here. And when you say kubectl get deployment, you will see there is a webinar here. And also when you say kubectl get pod, okay, it is running right now. You can check the logs. kubectl logs. As you can see, this is the very basic Spring Boot log. And right now, I will expose this one as a service. So I am saying that kubectl expose pod. The pod name will be different, by the way. Let me change it. The pod name is not this one. It will be this. And saying that I will use 8080 port, target port will be 8080, and the service type will be not port. So I will explain this service type in the upcoming webinars also. Now, when you say kubectl get service or SVC, whatever you use, now I have this dedicated service right now. Okay. Here I have service, okay? In normal production life, we use load balancers in order to access. So we create load balancers by using nginx egress, and then when you go to the load balancer, according to your domain name and the path, it will be automatically proxy to the backend services. But right now, in order to make it simple, I will use kubectl port forward command. So when you say port forward and your pod name, and just say your port, the pod name, and just provide your pod name, when you do this, it will be something like this. When you open this URL, it will be automatic. The request will be automatically proxied to this pod by using this port. Okay, let me open this. Okay, this is white label, and let me check if actuator is okay. As you can see here, when you provide your health, it is up. So we deployed our project here into Kubernetes cluster. You can also see this one, this project within your UI. Okay, I will refresh this page. Okay, we need to switch to the default namespace. And as you can see here, the deployment is here, ready. When you check the pod part, you can also see the pod. And when you click on that, you will see the details, in which node it is inside, what is the labels, what is the, who created this one, I mean the replica set. You can see the events, you can see the volumes if there is any. And also you can exec into this pod and you can see the logs also here. It is very simple. The same logs exist here. And also when you do an exec, you will be automatically prompt to this container. So let me check if, as you can see here, the app jar exists inside the container. In my daily life in Hazelcast, while we are developing Hazelcast Cloud, I simply use the terminal because kubectl is the simplest one for me. I operate all of my works within the Hazelcast Cloud by using kubectl. But if you are the starter one, you can use also this UI in order to see what's going on. But at the end, if you know or if you learn the kubectl commands in order to operate your Kubernetes cluster, it will be the best for you. And in 2 weeks, I will plan another webinar about the other topics like deployment pod services. I will provide the theoretical information first, and then I will provide you the real life use case about these creations. If you have any kind of question, you can type in the chat, or else we can finalize the session right now. Okay, if you have any kind of question, you can just find me here. Okay, you can find me on the social media, and then you can ask any kind of question about your current use cases. Thank you all for coming to this session, and see you in next webinar.